Now that we have our interceptors, we can make authenticated calls to our escrow API service. In order to do that, we will first create a config file, which will hold our escrow API service URL. Next, we will create a hook, which will retrieve our data for both the received and the created offers. Given they both endpoints return the same interface, we will share this hook between the two endpoints. We will define the interface, the properties interface of our use offers hook. We will also export it, because we might use it later. We will have an endpoint parameter, an action label. This will be the label on the table buttons, like confirm or cancel offer. An action callback, which will be a function that receives an offer ID parameter. We will return nothing, and an action in progress flag, which is an optional Boolean parameter. We will also want to add the IOfferResponse interface, which is the interface that the API responds with. So both our received endpoints and created offer endpoints return the same interface. This will be a single offer, which will have an offer ID, a creator, which will be the address of the creator, an offer payment object, which will contain the amount, the token identifier, and a nonce, in case this is an NFT. Then, we will have the accepted payment object, which will have the same structure, and an accepted address. This is the address that we want to offer the amount of token for the NFT. We will add the parameters to our use offers hook. And we will use the useAxios hook in order to retrieve our data. This will give us a data object, a loading state, and an error state. And we also can define the handler that we can manually use to get the offers. We will call this getOffers. This will return an array, an IOffer response array, and we will pass the Axios options, like the URL that we want to call, which will be the URL that we have defined in our config, and the endpoint that we want to call, which we receive as a parameter in our hook. We will also define the method of the request, which in this case is get. Given that our hook will return a table rows element, we will define the table rows variable. Which initially will be an empty array, and will have the type of array of JSX elements. We will also create a function that will create the table rows, not before creating a flag that will tell us when the elements were created. Initially, this would be false, because no elements were created yet. And we will define our function that creates our elements. We will receive an IOffer response array as a parameter. And we will build our table rows elements here shortly. Now we can create a use effect that will call our createElementTables function. So if we have a data object, then we can create our elements based on this data. And this use effect will listen for data and action in progress. So every time data changes, or action in progress changes, we will redefine our elements. Let's see what our hook will return. So it will return the table rows, the loading state, which will be composed of either loading or not having any elements created. And of course, it's not in the error state. We will also return the error state. And the refetch handler if we want to refetch the offers manually from the parent. This is our getOffers handler here. Now let's see how we can implement our createTableElements function. We will define a rouse constant, which will be an array of JSX elements. and it will be empty in the beginning. Then we will iterate through the data that we received as a parameter for this function. We will define a row constant, which will be an array of JSX elements. Then we can push our row into the rows array. Of course, now it's empty, it doesn't have any elements. And lastly, we can set the table rows to all rows. And also we can set the elements created to true, because we have finished creating the elements. Small typo here. This should be initially false. Now let's create one row of our table rows. Our table rows elements. Our first element will be the offer id. The second element, it's our creator address. And because this is a blockchain address, we can use the trim component of SDK dApp in order to trim the address based on the user viewport width. Going further, we can add the offered payment. So we will add the offered payment amount and the offered payment token identifier. Next, we can add the accepted payment amount and token identifier, same as above. Then we can add the accepted address, which, of course, again, it's an address, so we can use the trim component. And lastly, we can add a button. Let's add an undefined placeholder for this button, and we can add the action label. Then we can add the onClick event, which will call our action callback with the offer id. It will also be disabled if any action is in progress. And we can add some size, small size, a variant, outline, and some color. Let's say blue-gray. Now we can retrieve our data with our hook. We can test it really quick in our dashboard. Let's say we want to import the table rows. And we need to pass the endpoint that we want to call, which will be offers created. The action label, let's say it should be canceled, because we would like to cancel any created offers. And the action callback as a function. Let's make that empty for now. Now, if we revisit our app, we can go to our Network tab and refresh it. And we can see that the created endpoint has been called. And as expected, the created offers array is empty. We can change this to received. And for the sake of this tutorial, let's make this labeled approved. We refresh the page and we can see that now the received endpoint was called. Again, with an empty response.